Welcome to Not Factory Approved, the channel where I attempt to show you how to get into trouble creatively. Today's adventure concerns a Mig Welder, Exhibit A. Some time ago I had a Mig Welder that I bought used and the handle broke. So I spent a long time trying to find a replacement handle. It was kind of an obscure brand and I could never find one. Well, I had repeated dealings with a local dealer for Air Liquide, and I kept asking him about a handle, and he'd try and help me, and it would never work out. So one day I went in and asked him again if he had any used handles around. He showed me this welder. It was brand new. I said, "What's wrong with it?" He said, "No idea. Brand new, came in, never worked." And why they never sent it back, I'm not sure. But he said if I give him 25 bucks, I could take it away and use the handle. So I thought, what the heck? I worked on it. I thought if I can get this working, why bother adapting this handle to the other machine, which is an obscure make anyway. So this one is it's actually made in Italy, I believe. I forget the name of the company at the moment. And Air Liquide is the dealer. So I paid the 25 bucks and I took it home and drew out some schematics. I was able to find this schematic, which is for a similar unit, but slightly different. This one has a more complicated power switch for the various levels. So this was a simpler unit. But what I found after tracing everything out the hard way was that the neutral was miswired on the switch, so it could never turn on. So I repaired that, and it's worked fine ever since. So the lesson for this is don't be afraid to draw things out. It does take a while, especially in something like this, where the wires are all black. In some cases there's indicators, markings as to what the wires are. But mostly it's just tracing it out, disconnecting and ohming it and making sure you've got the right wire, and then drawing where it connects in the circuit. So laborious, but now I have a Mig Welder for 25 bucks and a bit of labor. I found some information online for an OptiWeld M90, which is the manufacturer, but a different model. And it was close enough that it was sufficient to help me get started. So based diagrams on that and found out any differences there were. And drew out the control board and did some troubleshooting. And what I found was that somebody had taken the neutral wire and they'd put it on the wrong side of this switch. There's actually a relay that pulls in this unit, so it's slightly different. And they had it on the wrong side of the relay, and the relay could never engage. So, no power. Change that. One weakness it has is that it feeds the wire too quickly. And I'll show you that. And what I've done to try and cure that problem. And we'll see if it actually works over a period of time. So I've modified this, so now it feeds much slower. Still variable. This is a 110 volt low power unit. It certainly works for anything I need it for. If you turn it on, this is the speed control. I have it set to minimum. It's feeding it out. Even with 30 thousandths wire, it's still feeding it out way too fast, especially for very light sheet metal. I also drew out the control board because I thought there might be a problem in that initially, and it seemed the easier thing to do since it's a fairly small and not complicated board. For the problem of it feeding too fast, so to control the speed, what I did was the motor is on this side. It has this friction clutch here. Puts friction on the cable, which pushes it through the line to the tip. I'm adding a switch. A double pole, single throw, sorry, single pole, double throw switch with some resistors. These are a minimum of 1/2 watt. I believe they're wire wound, so they might be 1 watt. But they're just scrap ones that I had. I tied them all together. They're a very similar resistance of each one. I found that 10 ohms made it too slow at the minimum setting, and sometimes it couldn't move the wire because it insufficient power for the motor. I've cut it back to 5 ohms, calculated it out. We should be getting a maximum low speed of about well, less than 1/4 of a watt anyway, which those resistors are certainly sufficient for. I will have to remember that I can't control the speed past a certain point, because that will supply more power through the resistors and therefore could overheat them. We're cutting the line for the motor and inserting a switch and some resistors, so it can either be full speed on this side, so plus voltage feeding in from the board straight to the motor, or it will go through a resistor to the motor. Ideally, since this is a pulse width modulated controller, it does not control the voltage so much as it controls the duration of the pulse that drives through this SCR and ends up at the motor drive, pin 7. If I wanted to spend the time, what I should actually do is go through and calculate values for resistors and how I can change the circuit to vary the pulse width modulation. But I'm not willing to put that much time into it. I think this should work sufficiently. If it doesn't, I'll go back to the drawing board, but I'm not expecting any problems. So I've drilled a hole in the front where the switch will go, and then I will mount it with some metal in this vent so that air will flow over it, and I expect that it will work just fine. It will certainly give me a better feed for wire for welding very thin metal. So I'll have to make a label yet, but there's the finished job. It has normal speed, slow speed, off in the middle. This just happened to be the switch that I had. Attached a screw there with a clamp that holds the resistors and acts like a bit of a heat sink, and it's in the airflow area. Air enters through there. It's blown out by the fan at the back. And I'll show you the difference. Right now I have it set to speed of 4. Turn it on. Normal speed. Comes out fairly quickly. Slow speed. Much slower. And nothing. This is the meter that I use. It's just a cheap, I think I paid $12 for it. It might have been 20. Can't remember. I've had it for a number of years. There's a number of functions. It is not auto ranging. It's a manual range. So you'll have to make sure, especially with voltage, AC or DC, that you always start at a high number and work down, or you can blow it up. It has some other functions, AC amps, DC amps. This is the control board. As you can see, the main control component is SCR BT151, and the gate of that is controlled effectively by TR1 MPSA42 transistor. The base of that transistor goes to the pulse width modulation network, which consists of R9, pot1, R6, 3 diodes, and a capacitor. So depending on where the pot sits, you will control the oscillations as far as pulse width is concerned, which will turn on the transistor at different rates, resulting in a different pulse width on the gate of the SCR, which then passes power through R5 to the motor drive line. Gas solenoid is over towards the top right, and the AC in on the chassis mount relay, and before the neutral was connected to the wrong side of that relay so that it could never actually pull in. So there was never a connection between neutral through the transformer and the AC hot. This is the wiring diagram for the M132. You can see the 4-position switch coming from the power cord. On the left-hand side, that turns power off and on. The 4 lines that come out go to the windings of the transformer, which then control the amount of voltage that's derived on the other side. The control board has a relay that is pulled in, and that relay, if you go over to the control board, determines power to the gas side and the chassis mount relay. Now, over on the other side, there's the bridge rectifier coming out of the transformer. That is for the 140 volts DC maximum. And then you go through the hand switch, and that sends the 140 volts switched to the control board as well, so that everything turns live when the hand switch is depressed. So this is the 10,000 steel. Tried doing butt joints and it couldn't handle that, but if I'm careful I can do lap joints, so that is a vast improvement. 10,000ths is pretty thin stuff, so there is hope.